Good morning to all of you. Welcome back to Hospitality Engineering. Today we continue Energy Conservation and Energy Efficiency Module 12. Energy, Part 4. Small to large savings at reasonable cost. First, we will recap our last video. In previous video we learnt about Type 1. Greatest savings at least cost in energy conservative measures. In this video we are going to discuss about Type 2. Small to large savings at reasonable cost. General equation used to calculate savings. Savings equals baseline energy minus post-installation energy, plus or minus adjustments. Two fundamental factors drive energy savings: ECM performance and use. Performance describes the rate at which energy is used to accomplish a specific task. Use describes how much of the task is required, such as the number of operating hours during which a piece of equipment operates. For example, in the simple case of lighting, performance is the power required to provide a specific amount of light, and use is the operating hours per year. For a chiller, which is a more complex system, performance is defined as the energy required to provide a specific amount of cooling, which varies with load, whereas use is defined by the cooling load profile and the total amount of cooling required. Both performance and use factors need to be known to determine savings, as shown in above equation. Let's see this general equation in graph form. The area of the large box represents the total energy used in the baseline case. Reduction in the rate of energy use, increase in performance, or reductions in use, decrease in operating hours, lead to reduced total energy use, which is represented by the smaller box. The difference between the two boxes, the shaded area, represents the energy savings. Install submeters. Modifications and improvements offers wide savings, such as manually resetting temperature controls, changing operating times, closing steam valves to the laundry, adjusting fuel or air ratios on combustion equipment, checking chillers for non-condensable or for low refrigerant charge, installing submeters, etc. Improve chiller efficiency. Check cooling capacity at loads of 25, 50, 100% and compare with equipment design data. Reduce head-on chiller use, lowest possible condenser and highest possible evaporator pressure to just satisfy load. Automate by installing microprocessor controls will achieve 1% saving. Absorber chiller economizer reduces quantity of solution pumped to generator at partial loads. Keep valves to offline chillers closed. Check regularly for non-condensable in centrifugal chillers and for quality of the vacuum in absorbers. Improve cooling tower efficiency. To maintain constant temperature, don't run cooling tower cells without fan or bypass condenser water. Install 2-speed control for fan and cut down fan speed. Replace inefficient fill with cellular honeycomb fill to optimize atomization of water droplets and extend contact time with air. Ensure proper water treatment. Biological fouling obstructs fill and causes loss in heat transfer efficiency. Install automatic blowdown and use effluent for irrigation. Ensure even water distribution at deck and nozzles. Improve boiler efficiency. Check combustion efficiency at loads of 25, 50, 75, and 100%. Check for drafts and install automatic draft control if excessive. Ensure that burner dampers close when in off mode to reduce draft losses. Check for steam and condensate losses. Maintain boilers in optimum condition. Preheat heavy fuel to 80 degrees Celsius. Recover flue gas energy. Close daily steam supply to the laundry, kitchen, etc. after working hours. Check and improve pump, fan, motor efficiency. Obtain performance curves and compare the actual performance with the design. Modify the pump impeller if required. Replace burnt motors with a high-efficiency type. Check chiller and boiler heating coils use cheapest energy source.
For example, absorption versus a centrifugal chiller. Steam versus electrical heating. Gas versus fuel oil. Direct versus indirect heating. Hot water versus steam.
Install thermostatic controls and time clocks. HVAC controls prevent waste of fuel and electricity include optimum start and stop controllers, weather compensators, zone controls, room thermostats and thermostatic radiator valves, setback controls. Install occupancy-linked controls. Install energy-saving controls like
room-based keycards and fobs, occupancy sensors, central systems.
We have come to end of this video and hope you have subscribed for channel. If not, like and share this video and subscribe to our channel for more training modules. The next topic on moderate to long payback periods. Thanks for watching.